And you guys are going to want to go swimming.
Wait, are we starting now?
Who?
And this is Professor Berenbaum with Professor Gene.
Yeah.
This is the director's cut of the explanation of our names for the theorem of Pintel and Ragetti, which we invented about half an hour ago.
Yeah, it was
handout. It was what? Professor Gene? Professor Gene. Okay, well, Professor Gene's name came from the story that we invented last time I came to Sam's house. And it is a funny one. According to Sam...
Quite.
According to Sam, me and him had gone to Africa yesteryear when we were -5 years old with Robert Callahan, otherwise known as Bobby, who is now in Valley Forge Academy for the Incredibles. That's another story. But during this time, I had a baby racquette in my small toe, which he had named Gene. And it had been hiding there until it could come out when I started playing tennis. Now, an explanation of my name. As everybody knows, there's a smaller child that lives next to Sam's country house who looks exactly like me, except is small. That's where Professor Berenbaum is. Ready?
Yeah.
Okay. This is Professor Gene and Professor Berenbaum here speaking to you about the Ragetti and Pintel Theorem, which we invented 30 minutes ago.
Roughly.
To explain how many hours or minutes it would take us to get there from a certain point to Sam's country house. Oh, I'm sorry, Professor Gene's country house.
Yes. Professor Gene, please.
Sorry. To start off, we thought to explain how long it would take to get to Professor Gene's house, we would have to use the analogy of a pie or multiple pies.
Oh, yeah, one or more.
One or more, probably two. And in these pies would be a certain slice of one of these two pies, we're not sure, that would explain how many hours it takes us to get to Professor Gene's house. And now, if we can't actually say exactly how many hours, so we will have to use minutes instead. But to get to the minutes formula, we will actually have to use...
Oh, hang on a second. I want to get this on tape. Look at that.
Back to our main theorem story. To get the theorem, you have to actually use an intrinsic formula for minutes. And this minutes formula is you have to divide the hours by 60.
60, take that number down.
And that would equal the amount of time it would take one man to build a rocket, launch it to the moon, and survive there. During this time, he will be living on the moon. And we take that time and multiply it by 200 wires.
200 wires, that's it.
Wires. And wires is a measurement formula that we will also explain during this 30-minute program. This is the time we'll take to have you, our viewers, call in for some questions. This is the Pintel and Ragetti Theorem program. What is the caller's first question? We seem to have lost him. Let's go back to the theorem, and maybe he'll call back.
All right.
So we were talking about the wire equation, and wires is actually significant because we use the measurement that we guesstimated of the size of a...
It was really guesstimation on this one, really.
Of how big the bumper of a van, of any random van that passed us at that certain point was. And we guesstimated that it was about 1.5 minutes after Sam's watch.
Yeah, about a minute and a half.
And multiply by any random number, we got 30 minutes.
Yeah.
So you subtract that from 200, multiply it by the amount of rivers we would pass to get to Long Island.
And here's another, it's another guesstimation at this point. That's about 30, I think.
Roughly. And multiply by 30. And after this, you get to the hard part.
Yeah.
The really tricky one.
We're going to pay close attention to this part.
The one that might get away. We passed a sign that said,
you know,
55 miles an hour.
At this point, I think I'd like to interject. It's like, you know, when you're on the highway, you know, you're bound to pass something. It could be anything. Anything at all. But you're bound to pass something. Really, you are. So
This is part of the formula, may I add.
yeah. So we passed a sign. Okay, let's continue. So the sign we passed said like 55 and 40. With two numbers in the sign. Two numbers for the equation.
I want to take this moment to introduce the product that we'll be selling on this program. Mango Madness Snapple has an explosive flavor. Don't take while lapping. The sign, as we were saying, had the two numbers 55 and 40. We used this to calculate that when the highway had opened in 1967, the winter of 1967.
It was in the winter. It was a wintry day.
It was winter. It was cold. It was shining. The sun was falling. And these two cars were going at those two exact speeds. And we had said that they crossed each other at the exact moment of the coinciding parallel universes.
Yeah. See, at this point, you really want to start thinking in the fourth dimension. Yeah. It's not going to make sense if you start thinking realistically.
Now, when these two crossed in the two parallel universes, they actually form a rift in time and space. Now, this causes all sorts of problems for our formula.
Yeah.
Now proving that our formula is impossible.
Yeah. Because we're never gonna know. Because these two guys.
It happened in 1967.
These two chumps, with their 55, 40 miles per hour. I mean, they could have been anywhere. They could have been
any part of this highway, any part in the wintry nights of 1967.
Thus proving our theorem of Pintel and Ragetti.
Impossible. Sorry for wasting your time.
Oh well, sorry.
Congratulations! By buying the extra $50 for this DVD, you got the extra special bonuses! Bonuses! Yes!
In this special bonus feature of the Director's Cut, we're going to show you the callers that didn't call. That's one of our callers. Hello?
Hi, I would like to ask, does the Pintel and Ragetti Theorem work for all people's country houses? Could you actually find the time to get to anybody's house in the world?
Well, of course! I mean, what do you think? Is this kind of some kind of scam to get a Nobel Prize? What do you think? Oh my god! Ah! Ah! Okay, alright, now back to the theorem. This is a blooper. Director's cut? What? Wait.
Wait, hold on.